first question says he wants to create a system of equations that so that the system has no solution. Which of these can Steve do? So first off, a system of equations that has no solution is going to be a graph that has two parallel lines. So it has the same slope but different y-intercepts, which you got. You said it had an equation with the same slope and different y-intercepts. So create a pair of lines in which one line lies directly on top of the other. That's actually an infinite solution equation. Create a pair of equivalent equations. If they were equivalent, it would be infinite. And then you did say create a pair of lines that will always stay the same distance apart, because it would create parallel lines. And then creating a pair of lines that intersect at one point has one solution. So you got the two correct answers. It's just you clicked one that was also not correct. Okay, which system of equations is correct? So the way that I would do this, because it gives me the ordered pair, so it's at the point 4, -2. So I'm going to substitute it into each one equation to see if it's true. So in the first equation, 4 minus -2 is equal to 6. So that is correct. And then 4 times 4 plus 3 times -2 does not equal 1, because it's 16 plus -6, which is 10. So that makes that incorrect. The next one, we already know the first equation is true, so let's try it here. So 3 times 4 plus 4 times -2 equals 4. That is correct, because 12 plus -8 is 4. So that's why this was the correct answer. But we should double check the other ones. So this one is 4 minus 2, the 4 plus -2, equals 2, not 6. We already know that that equation is incorrect. So now we know that the equation is incorrect, and we know the bottom one is incorrect because 3 times 4 minus 4 times -2 is going to be 12 plus 8, which is going to be 20, not 4. So this one, 4 minus 2 does not equal 2, not 6. Not equal 6. Okay, so then we know that was the correct answer. So I would use the answer to help me figure out the correct answer. Okay, the graph line shown below is y equals 5x minus 10. Which equation when graphed with the given equation will form a system that has no solutions? So we're looking for one that has the same slope but a different y-intercept. So it's not the first one because the slope has to be 5x. The second one is y equals 5x plus 10, which is why it's the answer, because it has the same y-intercept or slope, but a different y-intercept. The next one is y equals 5x minus 10, which is the same equation. So that one is not correct because that would be infinite solutions. So it's this one. Okay, the expression on the left side of the equation is shown. If the equation has no solution, which expression can be written in the box on the other side? So we're looking for one that would be the same slope but a different y-intercept. So let's simplify this one. So I'm going to get 3x plus 3 plus 9, which is the same as 3x plus 12. So I'm looking for one that's 3x but a different y-intercept. So the first one is 3x plus 12. Go tell them to stop. The next one is 2x plus 12 plus x, which is also 3x plus 12. So far the first two are infinite solutions. The next one is 4x minus 12 minus x, which is equivalent to 3x minus 12. That's why this is the correct answer, because it has a different y-intercept. And then the last one is 3x plus 3 plus 9x, which is 12x plus 3. So that one has one solution. So it would be the third one down. That was the correct answer. All right, Noah hopes to pick the winning ticket during her math class raffle. The student who picks the ticket with a true statement will win. Which is the winning ticket? Okay, so we need to make sure it's true. So this first one says that this is equivalent. So we would simplify it and do 4x minus 20 equals 35. So we'd add 20 to both sides, which is 4x equals 55, not 40. So this one's not correct. The next one is 8x minus 56 equals 35. So we would add 56 to both sides and get 91 equals 8x, which is also not correct. The next one is going to be 2x minus 12 equals negative 35. Add 12 to both sides. So I get 2x equals negative 23, which makes this correct. The last one, we're just going to double check it. It's 9x minus 54 equals negative 35, and I'm going to add 54 to both sides. So I get 9x equals $19. So that one was not correct. Okay. It says Jeremy wants to determine the number of solutions for the equation below without actually solving the equation. So what we can do is simplify it though and see which one would be true. So we would get, if we simplified the one side, we'd get negative 3x minus 3 plus 3x. And on this other side, I'd get negative 3x plus 3 plus 3. So I'm going to end up with negative 3 equals negative 3x plus 6. And since it became when I simplified the one side of the equation, it ended up being just 0 because they canceled each other out. I know that it's going to be one solution. And so it's going to be this one, determine whether the equation has the form x equals a. And the equation has one solution. Okay. The expression on the left side of the equation is shown below. If the equation has infinite number of solutions, which expression can be written on the other side of the box? So we're going to simplify it. We're going to get negative 5x minus 10 plus 3x. So I'm going to get negative 2x minus 10. So I'm looking for one that has the same, as it has to be equal for them to be infinite solutions. So this one is negative 5x plus 15 plus 2x. So I know it equals negative 3x plus 15, which is not what I'm looking for. This one is negative 5x minus 10. I want it to be negative 2x. So I know that these two are incorrect. This next one is going to be 2x plus 2. I'm looking for it to be negative 2x. And the last one's going to be negative 2x minus 10. So that's why this was the correct answer. Okay, it says, Beanie solved the system equations by graphing. Which statement identifies the error he made? So you chose two of them. He graphed y equals x minus 3 incorrectly. He did the x-intercept instead of the y-intercept. He should have graphed the y-intercept of y equals x minus 3 at 0, negative 3, correct? And then the last one, he should have found a point of intersection. So if we had graphed it correctly, we would have started at negative 3 here, and we would have gone up 1 over 1. So 1, negative 2 would have been the correct solution.